this problem, we are given that the management of Titan Tire Company has determined that the quantity demanded, X, so I'm going to underline that, X represents the quantity demanded, of their Super Titan tires per week is related to the unit price P by the following equation where P is measured in dollars and X is in units of 1,000. So this is our function quantity written in terms of the price P. So we're asked to find the elasticity of demand for the price points $118, $96, and $66. And we want to know if the demand is elastic, unitary, or inelastic. The first thing we want to make sure is that the function is written in terms of P as the independent variable. So we need to have X by itself. Now remember that X is a function of P, meaning that X is the dependent variable, and the quantity, in other words, is dependent upon the price, where the price for us would represent our independent variable. Okay, so quantity and price. So we're given the formula here for elasticity, and on the test you will be given that formula. So let's first of all find that value. So our elasticity formula would be minus P times the derivative of our given function. So we're going to rewrite our function. X equals, I'm going to write this as 144 minus P raised to the 1/2 power. And I'm going to use the chain rule to actually compute that derivative. So that would be 1/2 times the inside function as is. Then I'm going to reduce that power by 1. So that gives me a negative 1/2 for that power. And I'm going to multiply by the derivative of the inside. So be careful here. The derivative of negative P is negative 1. All right? And that is divided by, according to our formula here, the original function. So I'm going to divide that by 144 minus P raised to the positive 1/2 power. All right, if we want to, we can clean that up a little bit. Let's just write this as I'm going to multiply negative P times negative 1. So I end up with 1 positive 1/2 times P. And I'm raising that, or multiplying that times 144 minus P to the negative 1/2 power all over that original function. Just a little bit of simplification makes it a little bit nicer to work with as we go forward. So there's our elasticity formula. And now I would like to plug in different price points and see if we have elastic, inelastic, or unitary demand. So I'm going to plug in 118 in place of P, so that's my price. So that's 1/2 times 118 times 144 minus 118, all of that raised to the negative 1/2 power, and then divided by 144 minus 118 raised to the positive 1/2 power. All right, so we can just throw that into the calculator as is. One thing that you do want to be careful about when you type this into your calculator is that when you type in this quantity, make sure that you have the parentheses. So when you type in 144 minus 118, make sure you have the parentheses. You'll use the little caret symbol, and we want to make sure that the power is not just negative 1, but it's negative 1/2. So I recommend that you put parentheses, type in the negative 1 divided by 2, and then close your parentheses. And that way you're raising it to the entire power of negative 1/2 and not just the negative 1. So when I type that in, I get 2.269. I'm just going to go ahead and round to the nearest 3 decimal places here. So what does that tell me? Well, we said that if the number that we get from our formula is greater than 1, then we will have elastic demand. All right, so let's look at the next value here. So 96. So we're going to plug that into our formula as well. So 1/2 times 96 times 144 minus 96 raised to the negative 1/2 power. All of that divided by 144 minus 96 raised to the positive 1/2 power. Okay, so once again, be careful about how you type in that exponent of negative 1/2 and 1/2. And when I get this, I get a 1. So if our elasticity of demand formula gives us exactly 1, we would say that the demand is unitary. All right, then lastly, we want to see what is the elasticity of demand for a price point of $66. So we're going to type in 1/2 times 66 times 144 minus 66 raised to the negative 1/2 power. All of that divided by 144 minus 66 raised to the positive 1/2 power. And so for this, I get it into type it in my calculator, I got 0.4231. So in this case, our elasticity of demand is less than 1. Therefore, we would say that the demand here is inelastic. Okay, let's just remind ourselves really quickly what that means. That means that the demand is going down by this value if we raise the price by 1%. So this is not enough of a decrease in demand for us to be concerned. So for inelasticity here, if my demand is elastic as my price goes up, the revenue also goes in the same direction. So in this case, we would want to raise the price to increase the revenue. All right, if the demand is unitary, then what that tells me is that 96 is the nice price here that's going to maximize the money that I can bring in. So that's going to maximize my revenue at that price point. It's kind of my ideal price that I would like to charge. And then lastly, if our demand is elastic, that means that our demand is actually decreasing by a pretty good amount. If I raise my price 1%, the demand goes down by 2.2% or so. So this is actually going to cause a decrease in revenue. So here, if I raise the price, the revenue goes in the opposite direction. The revenue will go down.